We all have a story to tell. Let's tell yours. Welcome to the Intellectual People Podcast with your host, Jason. Come together and listen to journey stories and more from interesting people. Welcome your host, Jason.
And now, here's part 2 of my time with Tom Christiansen of Neurochrome. Please go visit Tom at neurochrome.com. Do you get a lot of people that want to put the audiophile quality parts into it?
Not really. I usually discourage that.
Okay.
Just
And why?
Well, the audiophile components, I've measured a few of them. While I was at TI, I had access to an excellent impedance analyzer that I wish I still had. But it's so I measured like a fancy but not over the top, like a $20 coupling cap, silver and oil, yada yada film capacitor. I measured a $2 coupling capacitor with polypropylene dielectric, and I measured a 50-cent coupling capacitor just from DigiKey, and nothing fancy. It was a Panasonic cap, but also with polypropylene dielectric. And I found that the Panasonic cap was the better of the three. So it's like, why are you spending 40 times as much on something that's worse? That's not what I would do.
Why do you believe that is? Why would a hi-fi capacitor that so many people push and so many people buy, right? Why is it not as good as that much less expensive capacitor? What's in it that is changed, and why is the perception that it's so much better? Because so many people would argue with you and say they can hear it, they can hear it, they can hear it. Why is it?
Yep. And when I talk to people like that, I don't mean to put them in an us versus them, but when I talk to people who are passionate about capacitors make a difference, or resistors make a difference, or so on, I do my absolute best to not deny their listening experience, because I am convinced that when they make those circuit changes, they do perceive those differences. But I can come up with a lot of reasons from cognitive psychology for why that might be, or from social psychology of why that might be. If you just spent, let's take speaker cables as an example, just because they're frequently picked on. I mean, what matters with speaker cables is the resistance of the cable. This is very well documented. And what matters for the resistance of a cable is the cross-sectional area. And once you get above a certain cross-sectional area, there isn't really much to be had. So why do people experience a difference when they use speaker cables that are, as thick as my thumb? But I think a lot of it has to do with the fact that they just blew $1,000 on a pair of speaker cables. And there isn't a way in hell they're going to admit to themselves or others that it doesn't make a difference. And I've been in that situation too, where I changed something and of course it made a difference. I spent 8 hours making circuit changes. Of course it makes a difference. But then you come back the next day and it's like, I'm not sure. Or you change it back and it gets even better.
Right.
I mean, that's another common one.
So how much is this impedance tester that TI had?
You can buy them on the used market for about $5,000.
Well, I'm just trying to get a feel for because I think a lot of people will argue with you and say, well, I've measured it. Well, they've measured it, right, with a $100 LCR meter is what they've measured it, right? They haven't really measured the capacitor, right? And they
you might actually be able to measure it with an LCR meter, but you might need a slightly better one, like $1,000 one or something like that. But that's probably out of reach for many people, especially if it's just for a hobby use. I mean, I don't have an impedance analyzer like that because I would rarely use it.
Is there something else internally, whether it's resistors, capacitors, any other part, that quality of material, right? Everybody, oh, it's silver, it's solid silver, it's right. Does that really make a difference? If the value is the same, does any of that make a difference?
Yes and no. That's probably not a satisfactory answer. But I mean, one thing, to speak of the precious metals for a second, I mean, in the 80s was when the gold-plated RCA connectors came in, or at least that's where I started noticing them. And that was probably brought on by the connectors from the 50s and 60s that were tarnished. And there's no doubt that an oxidized connection is not a good connection. Sure. And you get vastly better quality if you have good connection. So then people did gold for a while. And then these days, gold is not fancy enough. It has to be rhodium plated. And I'm not really sure what's so special about rhodium aside from the fact that they can charge more money. And so there's usually some sort of grain of truth. And with capacitors, for example, materials do matter because some materials have what's called dielectric absorption. So basically, if you put a charge in a capacitor, connect a 1.5 volt battery to it, you remove the battery, you would expect that the capacitor stays at that 1.5 volts. If you discharge it to 0, you would expect that when you remove the short circuit to discharge it, that it remains at 0. But what happens is that it actually bounces back a little bit. So it develops a little bit of voltage. And I can certainly sort of hand wave my way through how that would create a distortion mechanism, because suddenly you have a signal dependent like memory effect essentially in a capacitor. So we choose capacitors without dielectric absorption effects. That's where the polypropylene capacitors come in. But that said, these effects are measurable. So like if you take a polyester cap and use it as a coupling cap, you will be able to measure higher distortion at higher signal levels. This is entirely quantifiable. Whereas polypropylene caps and also some of the more modern electrolytic caps don't have any impact on the audio signal, which is interesting. So the other aspect of this is the capacitor geometry. So you might have remembered from physics class, plate capacitor. You have two plates, one is positive, the other one is negative. Right. And if you want more capacitance, you put a dielectric in between because the dielectric constant increases the capacitance. And with foil caps, they're wound or rolled up, and the way they're wound can impact like the series resistance and the series inductance of the cap. So when you buy a capacitor, you don't just get a capacitor, you also get a couple of resistors and an inductor for free. But you usually don't want those. So the difference between a good capacitor and a not so good capacitor is that a good capacitor acts more like a capacitor and less like an inductor or resistor.
And what's your feeling on like a sandcast resistor in a speaker circuit, for instance?
I would argue that depends on what the resistor geometry is inside the sandcast resistor. I don't know exactly what they look like inside. What I would imagine is that it's a resistive element that's surrounded by sand so that you get a larger surface area. But I'm honestly not sure. Okay. There is a non-inductive way of winding a resistor where you wind the resistor one way and then essentially wind it the other way, so on the way back, so that the magnetic fields cancel, and that gives you much lower inductance. And I would encourage the use of that in an audio circuit, but I'm not really sure if it actually makes a big difference or not.
Have you had any conversations regarding capacitors and resistors with any of your suppliers or anybody colleagues that you've worked with that really know internally how they're made to kind of ease at your own mind about whether it's worth spending an extra $2, right? Because if for you it's not 50 cents to $2, it's maybe 50 cents to $4, right? So, and people always say, well, there's junk, there's junk, there's junk. Well, the reality is many of those people have never been in a manufacturing environment where 50 cents or a dollar doesn't sound like a lot of money. However, when it's thousands, or in the automotive world, it's millions, it adds up very quickly,
Yep.
right? So,
Yeah.
and you're in
I,
that same boat, because the reality is you're still a small company and you're there to make a living, not give stuff away for free, right?
yep. Yep. And that's actually an interesting conversation that comes up on a regular basis where some people will say, well, you use this component. Had you wanted to spend a little bit more, you could have gotten that component and that would have been better for these reasons. And that's fine. However, there is this thing called margin. And businesses exist to make a profit. I hate to put it that way, but that's how the world works.
Absolutely.
So that $5 extra for a volume pot might mean that the price of the product is like $20 or maybe even $50 more, which then puts you over some psychological barrier. For example, if the product is not $4.99, it's now $5.49.
Right.
And that changes your marketing. It changes people's perception of the product, and so on and so forth. But to go back to, I mean, there are differences in how components are made. And this comes out especially with surface mounted components. I typically buy surface mount resistors in reels, and they're typically either 4,000 resistors or 10,000 resistors. And if I have to spend an extra $1 per resistor, that means I'm putting $10,000 worth of resistors in my basement because I'm not going to use them all at once. And if I make a $10,000 investment in a reel of resistors, I expect to get a positive return on that.
Sure.
So there needs to be a good engineering argument for why do I need those resistors. And there are certain cases where, I mean, one of the processes I worked in a National Semiconductor was one we used for the precision amps. And it was a state-of-the-art, incredible analog optimized process. And one of the things that it had was thin film resistors.
Okay.
So I got into a little bit of the design considerations around how do you make a precision resistor and what are the materials and so on. And that, I mean, that makes a difference. And then when I moved to the precision timing group, where we were in a semiconductor process that was optimized for high speed and not so much for precision DC, I had to essentially make do with some resistors that were not that precise, that had a lot of nonlinearities, and I had to design some precision DC circuits around that. And I would consider audio to be precision DC, at least the levels I'm pushing. So that set me up pretty nicely for my Neurochrome adventure. And if you look at, I mean, it's less of an issue with leaded parts, so the parts where they have a pin in each end that you bend and stick into the board. But it's a bigger issue with surface mounted components because the components are physically smaller. So they have to make either the films that they use for the resistive element has to be thinner or made of a different material. One of these materials is like a thick film resistor. It's essentially like a conductive paint. And it turns out that thick film has a fairly steep voltage coefficient. So the resistor varies in resistance as function of the voltage across it. So if you put that in the circuit, in an audio circuit where it'll see some part of the signal, you will have a signal dependent error. We call it distortion. So there is definitely a case that can be built for using resistors. I mean, just like with capacitors, using resistors that have materials that have very few nonlinearities and therefore don't impact the signal that goes through them. But this is all documented in the data sheets, or at least to some extent. There's a little bit of experimentation that has to go on because something like a voltage coefficient is typically not specified because it's often not relevant. But it is relevant for low distortion audio.
Are surface mount components typically lower distortion or better quality than a leaded part, for instance?
It depends. So a surface mounted resistor can be as good as a leaded resistor. Where the leaded resistor is advantageous is that it's physically larger, so it can dissipate more power. And typically, it depends on the surface mount resistor that you get, but they have a temperature coefficient.
Okay.
So if the temperature changes, the resistance changes. So that means that if you have a resistor where you dissipate a lot of power, that resistor will go through a thermal cycle where at the peak of the sine wave, it's going to be really hot. At the zero crossing, it's going to cool down a little bit. And at the negative peak, it's going to get really hot again. So if you have a resistor with a high temperature coefficient, it basically means your resistance goes as function of the signal swing. And that introduces an error. So that adds distortion. So if you choose a low temperature coefficient resistor, you're usually better off. Where a physically larger resistor comes into play is that it allows you to dissipate more power in it, so it heats up less. So you have those sorts of considerations. But in terms of like, I can't draw a clear us versus them or
right.
SMD versus lead it, simply because it depends on the materials used and the topology.
And I want to talk about PCB design because from what I've read and I've listened to you, or I've read online and I've listened to you personally speak about, is PCB design and how critical parts placement is, and just the overall design of the PCB, which is something that I think you take great pride in your actual PCB design. Am I correct in that?
Yep, that's correct.
So do you model a PCB, because there's a lot of people out there, manufacturers included, that will purchase a PCB design software, right?
Mm.
They plug in what they want and it spits out a design, right? And they can use that design and it will work if they've properly inputted what needs to be done. However, it might not be optimized.
Right. I refer to those kinds of layout as a connect the dots layout. And I actually, my experience with that started in the IC world. I was designing a precision op amp where we were aiming for essentially zero voltage offset, and ended up arriving at a systematic offset of 400 nanovolts. The extremes of the distribution were plus minus 5 microvolts. That's the LMP 2021. That was actually a project I inherited from my skip level manager. So that was kind of interesting. Here's my baby, don't break it. So, but it was also an interesting project because part of that includes, there's a bit of the circuit where I have some MOSFET switches that are switching continuously. It's called a chopper stabilized op amp. So what you do is you cancel the offset by switching the input back and forth rapidly, and then switching the output back and forth rapidly at the same time. And the net effect is that whatever offset is there gets canceled out. And it works quite well, especially for a DC level circuit. I wouldn't use it in audio. But that crosspoint switch was an interesting design. I mean, I knew about like charge injection compensation and that kind of stuff from my grad school experience. So I designed the circuit, according to best practices. I simulated it. It worked great. I then proceeded to do the layout, and the performance degraded by, I think it was a factor of 100. It was one of those, wow, this went from this is awesome to this is broken overnight. Oh, this sucks. This is a switch. How hard can it be?
Yeah.
So I spent the next 2 weeks honing that layout. And what I ended up doing was to balance all the parasitics. And also those are like, if you have two metal traces that run like that on a circuit board or on an IC, there's some capacitance between them. Okay. And I had to balance all those capacitances and then balance the components. And it just has to do with moving them around physically in a way so that when they're produced on an IC level, that they're all identical and that they all see the same like electric fields and stuff, or the same voltage differences. And once I was done with that, the simulation showed that the new layout was, I think it was marginally worse. It was a little bit than the simulation without parasitics, and that was fantastic. So that really opened my eyes to, wow, my manager is right. He's telling me the layout is the circuit, and that's the one quote I have from him. And it's the same with a lot of audio circuits. For example, I was measuring an amplifier last night that I'm actually measuring from somebody on DIY Audio.
Okay.
And I noticed that its performance, so it's another low distortion amplifier, and its performance degraded a bit when I hooked up a transformer as opposed to just a laboratory power supply. And I'm like, why is that? And I think it might actually have to do with where the ground reference is connected between the signal ground and the power ground, because he has it connected at a point where there's a fairly large current flow. So I'm like, let me just try a quick hack. So I soldered on a wire and I connected it where I generally recommend the ground reference to be connected, and THD dropped.
How much?
It was a few dB.
Okay.
So definitely quantifiable.
Yeah.
Still wasn't quite as good as with the lab supply, but I also it was a quick and dirty hack. And what the designer of that layout had done was to connect the signal ground, the power ground, with a resistor of 1 ohm. And I bet if I took that out and had an actual PCB trace instead of a piece of wire, it would be line on line with the lab supply. So it's just stuff like that. It all has to do with figuring out where are the large current flows, and then staying away from those with your precision signals.
And is that something that you can do by looking at the PCB, or do you have to measure it and then go through an iteration to try to find out? Like how do you figure out how your circuit needs to be if it's, and I'm saying the PCB is part of the circuit, as you say. Yeah. How do you figure out how it needs to be part of the circuit?
Some of it is, most of it is based on theory. Some of it is based on the experimentation. But it basically boils down to that a PCB trace will have a certain amount of impedance, mostly resistance and inductance. The inductance depends on the length and also depends on the width of the trace, whereas a really wide trace will have less inductance than a very narrow trace of the same length. So that's why I'm a big advocate of using a ground plane, because that's the widest trace you can get. The challenge with a ground plane, if you just put everybody that needs to connect to ground on that ground plane, you will have one sensitive node somewhere in that circuit that is connected to some, let's just call it random position on the ground plane. Gotcha. And that means that, you still have the same currents flowing in the ground plane as you would in a circuit board trace. But with a ground plane, what you're dealing with is a lot of current that runs in the direct path from point A to point B between the heaviest source or the heaviest load. I mean, the current follows the path of least resistance.
Sure.
Applies, but it gets a little more involved when it's a ground plane, simply because you have a high current density between the 2 points where a large current is flowing, and then you have essentially, you could draw contour lines of 1 amp, half an amp, quarter of an amp, so on, between those 2 points. So you can find a quiet spot in the ground plane where hardly any current is flowing. And if you connect your quiet signal pad or your quiet signal ground at that point, you get better performance. Another part that or another argument I make is that you're trying to control the output voltage of your amplifier, so the speaker connection. So if you want a ground reference, the best ground reference is the negative speaker connection. And I have some simulations on my Neurochrome site under the taming the LM3886, specifically in the grounding article I have on that. Now my phone is ringing. Let's just wait for that to die down.
Understood.
It's probably somebody who tells me I'm being sued.
Oh, nice.
A common phone scam in Canada is that somebody calls you with an automated message. Your social insurance number is being sued, and we will have officers arriving at your door to arrest you unless you pay this money. Yeah, it's nice that they call ahead. It's pretty entertaining. So, all right. So with the ground plane or the ground reference at the speaker connection, I have some simulations on my website under the taming the LM3886 in the grounding section of that. And basically what I did for that was I assumed that you were going to have a certain amount of distance or a certain amount of PCB trace from your speaker terminal to your power supply. And then I played with different connections of the reference ground. And I can show theoretically that the best connection is actually at the speaker connection. And interestingly, that's the same argument as the guy, Andrew T. from DIY Audio used to make. So I sort of took what he had started and ran with it.
Okay. So a lot of your PCB design comes from experience.
Yep.
Fair to say?
Yep.
Yep. And where does Neurochrome go from here? What at what point does Tom offer consulting services to other companies?
Yes, he does. I do offer consulting services. I think I make a brief mention of it on my website. I used to have it more prominently.
Is it something that you push and you want to do, or would you rather build Neurochrome and TCA to larger companies?
That's a good question. I don't think pushing Neurochrome products to larger companies. I mean, I'm happy to license the designs to anybody who's willing to pay. The challenge is that the manufacturing cost, just the component cost, is too high for most manufacturers. I was approached by a company out of France that makes amplifiers, and they're basically, I mean, they kept asking, can you lower the cost? Can you lower the cost? Can you lower the cost? I'm like, no, go away. I mean, they were able to trade off on some features that they didn't need. They didn't need the balanced input, for example. I was like, okay, that saves you $5, or how much ever it was. And it's still, it wasn't enough to get there. And there are also companies like Hypix or Purify, for example, that make Class D amplifiers that they sell at incredibly low prices. And if you want a Class D amplifier, I will point you to them, simply because I don't have the know-how or the experience. I'm sure I can figure it out, but they have already figured it out. So just point to those guys. I did briefly consult for Mini DSP.
Really?
Yeah. I made the analog sections of the SHD. So they they had the 4x10 before. I think they still have it, but
Yeah, they do.
they wanted something that was higher performance because the main point of criticism was that the noise floor was really high on the 4x10. So they wanted an optimized design. And it was kind of interesting because they had actually approached a DIY guy about it before. And he came up with a design that I'm sure was brilliant, but required, matching of components and all sorts of stuff that is completely realistic to do in a one-off DIY build, but is completely impractical in a production environment. It can't happen. It's too expensive. So I was able to leverage both my circuit design expertise, but also my expertise in taking parts to production. I mean, the parts I made for TI have been produced by the millions. So I have a clue about how to do that. And I take the same approach as we did at TI with respect to like product quality. I wouldn't say I pretend that my circuits are going to be made by the millions, but I keep in mind that once I ship a product to a customer, my goal is to never see it again. I don't want a warranty return. I'm more than happy to help you out. If your product fails, of course, I'll honor the warranty. But my point is that I want the product to work until its end of life, basically.
Right. So how does Neurochrome expand?
That's a really good question. I mean, I sometimes wish that I could get help answering my email because I get a lot of, I mean, it comes and goes, but I get periods where I spend most of my day answering email. And these are deeply technical questions, obviously,
Right.
or in many cases. And it's not something that would be easy to outsource to somebody else.
Sure.
The remaining part, like circuit design, is something that I generally do sort of in the back of my mind. I'll get an idea for a circuit when I'm on a walk. And I mean, that's actually how the HPA10 came about, because I was thinking about how can I reduce the cost of the HPA1? And sat down on a park bench and enjoyed the view. And it's like, well, if I did this and if I did that, and then what if? And all of a sudden I had a product idea. And then, it's a couple of days of simulating and a couple of design iterations where, I mean, in the simulator where I tried one op amp or another op amp.
So you design circuits in your head like musicians write songs in their head.
Yeah, basically.
Incredible. So will Neurochrome ever have a D to A converter, for instance?
That's a good question. I think the answer is maybe. It depends. What I like about the DIY platform is that it gives me the opportunity to sort of test drive a couple of circuits before committing to a commercial product. So I could see having a D to A converter. It would be based on some chip. Sure. I personally favor the AKMs. Unfortunately, their fab burned down a couple of months ago.
Horrible.
So yeah, that's bad. It's going to take a while for that to come around.
One of the questions I have is there's some incredible DACs, really, really great DACs that are made overseas, right? And I'm sure you've seen the measurements of these on ASR, right?
Yep.
Why hasn't a DAC been made in North America that can compete with those DACs? I don't understand it.
I think you can compete, but possibly not on performance, simply because, I mean, the performance they're getting is the datasheet performance of those parts. And you can't get any better than that.
Right.
They're up against the boundaries of physics, just like the rest of us.
Right. But there's nothing made here. And an audio company that is very well known, has nearly a cult following in the States, has proved that manufacturing in the States can be done, and it can be done reasonably well in terms of cost, not quality, cost, right? The quality is great.
Yeah.
So there's nothing holding anybody back. We just need someone like yourself to design it, right?
Yeah.
at the $500 or $600 level, I would have to imagine that you'd sell truckloads of these things, right? And it bothers me because the technology is there, and if they can do it, there's no doubt that we can do it. And I say we, meaning somebody in North America, right?
Right.
And I look at you and I go, well, the one product that Tom's missing is E to A converter, right?
Yeah. Where I'm stuck a little bit right now is on the USB interface to it. The D to A converter part of it, I have basically solved. I mean, I did that for mini DSP, and I could do it again. I obviously wouldn't copy their circuit. That would be a trademark or an IP violation.
Sure.
But I would design something else. And the question is, can you hit that $500 price point? I calculated recently that if I want reasonable margins, so a margin that allows me to have maybe a couple of distributors that take their cut as well, I can ship you an empty box for $180. So that doesn't, I mean, that sets the bottom line for, I mean, if you want just a chassis with no functionality, it's going to be $180. So I cannot add a whole lot at the $500 mark. The question is, could you make a good DAC at the $1,000 mark and make money with it?
Right.
And what are some of the features of that? And I have some ideas. But where I'm actually at, to get back to your question about where does Neurochrome go from here? How does Neurochrome grow? Part of my strategy for growth is the fully assembled products. I've sort of I have deprioritized TCA a little bit, because Neurochrome was paying the bills, and I had tons of product ideas. Now I'm at the point where, thanks to COVID, I've caught up on all my back burner projects, and I've launched the products that I want. There are a couple of more projects that I could do, but what I really need to do is sit down and write a business plan. Because I mean, that's one of the things that is a little bit of a disadvantage as a sort of started as a hobby by accident business, is that I didn't do any of the planning up front. If I could do it again, I would have gotten a business license much earlier. And it's just, I mean, that's one of those lessons learned, right? And
And I think it's also worth mentioning that it was your escape because it was a passion and still is a passion, correct? You just happen to make a living from it now, right? So you mentioned TCA selling to pro audio side. Have you thought about that side of things, like microphone preamps, stuff that is, they're well done. However, they're not done Tom's way, right?
Yeah.
So have you thought about the pro audio world where there is an abundance of them and it's also a very different clientele?
Yeah, and a clientele that would probably plug in pretty well with my measurement focused approach.
Correct.
Because they care about specs and not so much about the superlatives.
Right.
And I have, thanks to some of the clients I have who are in the studio world, I've gotten some feedback on, well, this is what we care about. Your product must have these features. And some of the things are a bit surprising, like a digital readout of a volume or something like that, where it's like, well, I need to be able to return to the exact volume setting. Like, right. Oh, I hadn't thought of that. I just turn it until it's loud enough. And so I am certainly able to, or I'm certainly willing to entertain that idea. I think that could be an interesting market to play in. But I'm also seeing some requests for a more serious amp. I mean, all my products are serious in my mind, at least.
Absolutely.
But I think there is this ties back to the psychology again. I mean, if you don't charge $1,000, it's not serious.
Right.
And the question is, I mean, I would like to be able to sustain myself with maybe one or two helpers. But I mean, if I can keep it going on my own, I don't see why I wouldn't.
Sure.
So if I could sell, I don't know, 25 amps a month that I hand build, and where people get the personalized service and care that I think they deserve,
Sure.
then I think that would be ideal for me. The drawback of being alone is that it's really hard on the business when I then take a little bit of time off.
Right. Do you have, when you say more serious, are you thinking about more power or a more fancy casework?
Both.
Both.
Um, I mean, a premium product um, needs to feel good. I mean, that's the touchy feely part of the audio business, and I don't mean to degrade that in any way. I think it is important because it's your first, or it's part of the first impression of your product.
Absolutely.
Um, it's sort of similar to a luxury car, where when you sit down in like a high end Audi, it feels like a high end Audi. It doesn't feel like a Volkswagen, even though it's the same company. And even though a lot of the parts are the same,
Mhm.
um, and getting into that realm where, wow, this feels really good. It feels like it's solidly made. It would be made in North America, probably primarily Canada, because it's lower cost for me to ship it around, and I would rather that you pay for a good chassis design or good components than pay, shipping companies.
Right.
Right now, my chassis are made in Japan, and that's because I can get a standard chassis um, machined to incredible tolerances
Yeah.
for a not cheap but fairly reasonable price. Um, I mean, the length of the chassis is plus minus 0.13 millimeters, something like that. It's just, it's crazy.
Yeah.
And then, I mean, stuff like that. I mean, that's what they say. Well, that's our usual tolerance. We're usually finer than that. I'm like, all right, great. So that's pretty amazing.
Okay.
I love the quality.
So, is there anything else that you want to tell us, or anything that I haven't asked that you wish I did?
I think we covered pretty wide. Um, I think in terms of the Neurochrome versus TCA, like I mentioned, sitting down and doing a business plan, figuring out where do I go from here. That's sort of where I'm at.
Okay.
Long term, I mean, I would like to keep both going, but ultimately, I will have to figure out, well, which one of these provide more enjoyment, fulfills my passion better, and also, I mean, I'm not looking to get rich and famous, but I would like to at least be able to sustain myself.
Sure.
And so that's sort of where I'm at. Um, and I could easily see how they would complement each other. So, but that's long-term planning that needs to happen.
Yep. And I do appreciate it, Tom. I one of my wishes for this channel is not only educating younger generations and current generations, it's also a wish to bring companies together. And I'm hoping that somebody sees this, that has a company already that needs consulting work done, and reaches out to you. I really appreciate your time, your explanation. I believe I will have to split this into two parts because I certainly was not expecting it to be this long. However, I do appreciate it, and I hope that everybody else does appreciate it. And please subscribe, like if you liked it, reach out to Neurochrome and Tom by all means, and I'm sure he'll be happy to answer your questions. And he's very active on DIYaudio.com as well. And go visit him at neurochrome.com. Thank you so much, Tom.
Cool. Thank you.
Thanks for listening. Find us on YouTube and Facebook at The Intellectual People Podcast and online at theintellectualpeoplepodcast.com. Check back for exciting new episodes.